students, hope you are doing well. Welcome to my channel where we nurture and learn mathematics beyond boundaries. In today's video, we are going to cover the binomial distribution as part of the chapter probability from class 12 CBSE Applied Maths. In the first video of this series, we have already covered how to create the probability distribution table, basics of what is a random variable. If needed, go back and watch that video and then continue here with this binomial distribution. The link for the first video is given in the description below. So we have already covered probability distribution table in the previous video, and now we are going to talk about binomial distribution. Now let's first understand what is binomial distribution. After looking at the question or after reading the question, how do you understand that it is a question related to binomial distribution? So as we can see, the word binomial distribution or Bernoulli's trials, it's the same. So what is a trial? Either accepted or rejected, right? So a binomial distribution is applicable where you have finite number of trials for any given experiment, and this is known even before the experiment is done. Now each trial has two outcomes, either success or failure. That's why it is binomial. Bi means two. So there are just two outcomes possible, success or failure. And the result of any trial is independent of the result of other trials. Probability of success P does not change across trials. That means questions that involve this phrase with replacement. For example, you have a deck of 52 cards. Now if I ask you what is the probability of taking out an ace, so there are 4 aces involved, so it is going to be 4 out of 52, that is 1 by 13. Now if it is with replacement, I put the card back into the deck and then again I pull out again, then the probability of getting an ace will still be 1 by 13. But if I keep that card aside and then now, what is the probability of getting an ace next time? For example, for the first draw, it was not an ace and I kept it aside. Now the probability of getting an ace will be 4 out of 51, not 52. So the probability is changing with every trial. So binomial is applicable only when questions involve with replacement and the probability of success does not change across trials. Understood? Great. So let's first have a look at what is a binomial experiment and what is not a binomial experiment. So for example, toss of a coin 20 times. Now n is already known in advance, and record the number of tails. So how many tails you get? Either 0 or 1 or 2. So probability of getting a tail is also known, 1 by 2, and it is same across all the trials. So it is a question of binomial distribution. Rolling a dice 8 times and record the number of times an even number appears. Probability of getting an even number on rolling a dice is fixed, 3 out of 6. So it will always be 1 by 2. And n is also known, so that means this is also a scenario of binomial experiment. Next, drawing a card from a deck of 52 cards and record if it is a spade. Repeat the experiment 10 times after replacing the card after each trial. So it is involving replacement, that means the probability is not going to change across trials, and you need to record if it is a spade. So either it is a spade card or it is not a spade card. So there are two outcomes that are possible. Number of trials is fixed and it is with replacement. So again a scenario of binomial experiment. Now what is not a binomial experiment? Tossing a coin till 3 heads are obtained. Now here number of trials is not known before you start tossing the coin. So it is not an example of binomial experiment. Next, drawing a card from a deck of 52 cards and record if it is a spade. Repeat the experiment 12 times without replacing. So if it is without replacing, it is not binomial distribution. So please read the question very carefully. Next scenario could be drawing a card from a deck of 52 cards and record if it is a spade, club, diamond or heart. Repeat 15 times after replacing. Now even if it is after replacing, even if you know how many times, 15 times, but still this is not binomial distribution. Why? Because the outcomes of the experiment are spade, club, diamond or heart. 4 different outcomes. So the number of outcomes should be only 2. Success, failure. That's it. So first thing we need to understand is number 1, binomial distribution should have finite number of trials. Number 2, there are only 2 possible outcomes. One is success, one is failure. And the probability of success across trials remains the same. So these are the 3 conditions. When you read a question, just make sure that all the 3 conditions are met. Only then it is a question related to binomial distribution. Now how do we find the probability of our successes when we have a scenario of binomial distribution, there are n minus r failures because number of trials is n. Total is n, so r successes and n minus r failures. So if p is the probability of success, then the probability of r successes is given by NCR p to the power r q to the power n minus r. Understood? Great. So if you look at it, r and n minus r both add up to n. So the sum of the exponents of p and q is always equal to number of trials. Now in case of binomial distribution, if you understand that the question is related to binomial distribution and you need to find the mean or expectation, you need to just use this formula mu is equal to n into p. The best part is you don't even need to create the probability distribution table to find the mean here because it is just n into p, right? Variance is n into p into q. Again, the probability distribution table is just not needed when it is asking you to find the mean or variance or the standard deviation. So standard deviation is square root of variance, that is square root of n into p into q. Now this is a very important point that you should understand and always remember. When we calculate mean, variance and standard deviation, these are the three measurements that we do for any binomial experiment. Now after getting these values, how do you find whether the coin or the dice, it was biased or unbiased? There are certain questions like this also. So if the value of the mean and standard deviation is this, like suppose you have a mean of 100 and standard deviation is 20. So sigma is suppose 20. So 20 into 2 is 40. So something that is within 40 plus 40 and minus 40, we'll say this is an unbiased dice or a coin. But something that lies between 2 sigma and 3 sigma, that means 3 times of 20 is 60. So anything lying between 20 plus 20 and plus 60, that is 140 to 160. So it is going to be till 160. This may be biased, may not be biased. And anything beyond 3 sigma, so this is 3 sigma, anything beyond 3 sigma, if you get this measurements after doing the experiment, mean plus 3 times standard deviation and your observation is beyond that, that means the coin or the dice is biased, right? So we'll do questions related to this also and you'll understand it better, so it's okay. So let's start with the first question. It says, prepare the binomial distribution B4 2/3. So if this is just a notation, so if it is written like this, that means n is 4 and p is 2/3. Now because the sum of probability of success is always success and failure is always 1. If p is 2/3, q is going to be 1 minus 2/3, that is 1/3, right? Now whenever we start solving any question related to binomial distribution, always write the value of p, q and n and then only see how to solve it. So here you have n, p and q, all the three values with you. Now find the mathematical expectation also after making the distribution table. So what are the values possible for x? It could be 0, 1, 2, 3 and 4 because n is 4, right? Now let's find what is probability of getting a 0. Now this is just a notation, you can write it like this also, x is equal to r or pi or probability of ri. So this is just a notation, whichever notation you are comfortable you can use that. So how do we find this probability? It is going to be 4c0 2/3 to the power of 0 and 1/3 to the power 4 minus 0 is 4. So this is how we use the formula for binomial distribution. So how much is 4c0? It is 1. For any value of n, nc0 is always 1 and ncn is always 1. Both are always 1. So you don't even need to think. Anything to the power 0 is again 1 and 1/3 to the power 4. 3 3s are 9, 9 9s are 81. So that means the probability here is 1/81. Next, 1. So it is going to be 4c1 2/3 to the power 1 and 1/3 to the power 4 minus 1, that is 3. 1 plus 3 always add up to 4. The exponents add up to 4, so be careful with this. Sometimes you make mistakes while you are writing this, so be careful. 1 plus 3 is always 4. So how much is 4c1? 4. 4 into 2/3 into 1/3 cube. That means 4 is 8. 8/3 to the power 4, which is again 81. Now next is 4c2. 2/3 to the power 2 and 1/3 whole square. So how how much is 4C2? 4. 4 into 3 is 12. 12 by 2 is going to be 6. So it is 6 into 2 square by 3 square into 1 by 3 square. 2 square is 4. 6 4s are 24. So it is 24 by 81. Right? Now next it is going to be 4C3. 2 by 3 to the power 3 and 1 by 3 to the power 1. Now how much is 4C3? It is going to be 4. 4 into 2 cube upon 3 cube into 1 by 3. So 2 cube is 8. 8 4s are 32. So it is going to be 32 by 81. Last one. 4C4. 2 by 3 to the power 4 and 1 by 3 to the power 0. So 4C4 is 1. 2 to the power 4 upon 3 to the power 4 into 1. That comes out to be 16 by 81. Right? Now as you can see, the exponent for P is increasing from 0, 1, 2, 3 till 4, and for Q it is decreasing from 4, 3, 2, 1 and 0. So take care of the exponents of P and Q while you are doing questions related to this. Now the question also asks you to find the mathematical expectation of the distribution. For this you don't really need the distribution, just you need to multiply. What is the expectation here? So the expectation is n into P. So it is 4 into 2 by 3 and that becomes 8 by 3. Here, if you want you can leave it as a fraction or you can convert it into a decimal number. So it is going to be 2.67. Okay, next question. Find the probability distribution of the number of tails in simultaneous tosses of 3 coins. So how many coins? 3 coins. That means n is 3. And you need to focus on number of tails. So the probability of getting a tail is going to be P. So P is 1 by 2. Even though in this case Q is also 1 by 2. So it doesn't matter. But you should always focus on what is the random variable here involved. So it is the number of tails here. So what is the sample space here? Now is it really a question of binomial distribution? Let's first understand, because there are 2 outcomes, head and tail might be. Number of trials is known, 3 coins. So n is known and probability of head or tail is not going to change across trials. So yes, it can be solved using binomial. But because n is very small, when you have a value of n as 2 or 3, you can do it even without binomial distribution. So let's look at both the ways of doing it. So if x is 0, that means no tail. So what is the probability? 1 out of how many total outcomes? 8. So the probability of 0 tails is going to be 1 by 8. Right? If x is 1, that means you get 1 tail. So what is the probability? Number of favorable outcomes is 3. 3 out of total 8. So probability of 1 is 3 by 8. If x is 2, 2 tails. Again the number of favorable outcomes is just 3. 3 out of total 8. So probability of 2 is also 3 out of 8. And probability of getting all the 3 tails is again 1 by 8. So let's see how to do the same question using binomial distribution. You are going to get the same answer, so it is up to you what method you use based on the value of n. So how do we do it using binomial is, it is going to be 3C0 because there are 3 coins, and 1 by 2 to the power 0, 1 by 2 to the power 3. So this comes out to be 1 into 1 into 1 by 2 cube, which is 8. So that means the probability is 1 by 8. We got the same answer, 1 by 8 here and 1 by 8 here. Same? Yes. Next, 3C1, 1 by 2 to the power 1, 1 by 2 square. So this becomes what? 3 into 1 by 2 into 1 by 2 square. So that comes out to be 3 by 8. Again, it is the same value that we got without using binomial distribution, that is 3 by 8. Next, 3C2. 1 by 2 square into 1 by 2. So this becomes, how much is 3C2? It is again 3. 3 into 1 by 2 square into 1 by 2, and that becomes 3 by 8 again. Last one, 3C3. 1 by 2 whole cube into 1 by 2 to the power 0. So So that comes out to be again 1 into 1 by 2 cube into 1, and that is 1 by 8. So as you can see, if you solve the question using binomial distribution or without it, the answer is the same. So there is no change, just that the value of n was so small that it can be done even without binomial, giving you the same answer. Now the question said find the probability distribution. We have done that. Nothing to be done further, no calculation needed for expectation or anything, nothing is being asked in the question. So let's move to the next question. Two cards are drawn successfully with replacement. So here you see the keyword with replacement, that means it is related to binomial distribution. From a well shuffled pack of 52 cards, find the probability distribution of number of aces. Now here you need to focus on number of ace. So let x be the random variable representing number of aces. You have to write what is x. Whenever you are introducing any variable while solving a question, write what it is representing, only then move forward. So now what is the probability of success? That means the probability of getting an ace. And there are only 4 aces, so it is going to be 4 out of 52, which is 1 by 13. Now if P is 1 by 13, that means Q is 12 by 13. So we have the value of P and Q. What is the value of N? Now here a very common mistake is many children write n as 52 and then they get stuck how to solve it further. The value of n is 2 here, only 2 cards are being drawn out. So the value of n is 2. Before using any formula, write all the 3 values P, Q, N. So now we have all the 3 values and we can start solving this question. We need to find the probability distribution of number of aces. 2 cards are drawn. So what are the maximum number of aces that you would have? 2 or maybe 0. So the possible values for the random variable could be 0, 1 or 2. Now because it's a very small number, let's do it even without binomial also and with binomial and see how do we get the same answer. So if you do not get any ace, probability of getting a 0 ace, no ace, that means the first card is a non-ace card. So the probability is 12 by 13 and the second is also non-ace card. So the overall probability is 144 by 169. Now suppose you had 1 ace and 1 non-ace card. So what is the probability of x being 1? So probably you get 1 ace and then non-ace, or first you get ace, first you get a non-ace card and the second card is an ace card. So you need to consider both the scenarios. So probability of getting an ace is 1 by 13. So this will be 1 by 13 into 12 by 13 plus 12 by 13 into 1 by 13. So it is basically 2 times this expression 1 by 13 into 12 by 13, and that comes out to be 12 2s are 24, so it is going to be 24 by 169. Now what is the probability of getting both cards as ace cards? So first one will be 1 by 13, second again 1 by 13, so it comes out to be 1 by 169. So let's see, using binomial distribution, how do we do the same question? So as n is 2, it is going to be 2c0. P is 1 by 13, 1 by 13 to the power 0, and then 12 by 13 to the power 2 minus 0 is 2. So this comes out to be 1 into 1 into 12 square upon 13 square, that is 144 upon 169. Next 2c1, 1 by 13 to the power 1 into 12 by 13 to the power 1. This is going to be 2c1 is 2 into 1 by 13 into 12 by 13, so that comes out to be 24 by 169. Next 2c2, 1 by 13 to the power 2 and 12 by 13 to the power 0. 2c2 is 1, so 1 into 1 by 13 square into 1, that comes out to be 1 by 169. So as you can see, the probabilities are same whether you have done the question using binomial distribution or without it, because the value of n was very small. So for very small values of n, that is just 2 or 3, then you can solve the question even without binomial distribution. So you'll get the same answer. Okay. So let's move to the next question. A fair coin is tossed 9 times. So that means the value of n is already known 9 times. Find the probability of exactly 5 tails Probability of getting a tail is also fixed across trials, and there are only two outcomes. That means this is a question for binomial distribution. So P is this, and probability of getting a head is also 1 by 2. So let's solve the A part. Getting exactly 5 tails. That means we need to find probability of x being equal to exactly 5. So this is 9C5. First write the formula before you move forward. NCR P to the power R Q to the power N minus R. Always write the formula and then put it. So it is going to be 9C5. What is P? 1 by 2. 1 by 2 to the power R, which is 5, and 1 by 2 to the power N minus R, which is 4. So eventually the exponents add up to 9. So because the probability P and Q are same, so in questions where P and Q have the same value, you can straight away write the probability raised to the power N. So this can be written as 9C5. How much is 9C5? Let's do it. 9C5 is 9, 8, 7, 6. 5 factorial goes away. And then you have 4 factorial, 4, 3 and 2. So this is 9C5 and 1 by 2 to the power total 9. So these exponents get added up and it is 1 by 2 to the power N. So where you have probability P and Q same, you can straight away write P to the power N. So let's solve this. 3 to the 6, 4 to the 8. Now this is going to be 63 upon 7 to the 14, and then 14 nines are, and then 2 to the power 9. So once you do all the calculations, you get it as 63 upon 256. So this is what you get for this. Now let's come to part B. Part B is at least 5 tails. That means P, X, at least 5 means 5 or more than 5. So it is greater than or equal to 5. And how do we find that? So it is going to be P5 plus P6 plus P7 plus P8 and then plus P9. Now it's your choice. Either you do it like this, 5, 6, 7, 8, 9, add all the probabilities, or you can do 1 minus probability of 1, 2, 3, 4. So you can subtract that from 1 also. So it's the same. You'll get the same answer. So let's do it further. So it is going to be 9C5, 1 by 2 to the power 9. I'm straight away writing half to the power n now. 9C6, half to the power 9 plus 9C7, half to the power 9 plus 9C8, half to the power 9 plus 9C9, half to the power, okay, it's still 9 only. No, we have 9C9 also. So it is 9C9 half to the power 9. Right? Now let's take 1 by 2 to the power 9 common out. How much is 9C5? 9C5, when you calculate this, it comes out to be 126. 9C6 is 84. 9C7 is 36. 9C8 is going to be 9 and 9C9 is 1. So add all these numbers, 126 plus 84 plus 36 plus 9 plus 1, it comes out to be 256 upon 512, and that is equal to 1 by 2. So it's better if you give the answer in the lowest form, otherwise it's okay. You can leave it like that also. So the C part says at most 5 tails. So now we have at most 5 tails, that means x is less than equal to 5. So now when is x is less than equal to 5, and we have already calculated 5 and above. So let's see how we can do it faster. So let's use 1 minus probability of getting what? Less than equal to 5. Less than equal to 5 means if you take away all the bigger probabilities, that means probability of 6 plus probability of 7, 8 and 9. Because we have already done all these calculations, so it's easier like this. So it means 1 minus, from all these expressions, let me take 1 by 2 to the power of 9 outside. Now here I have 9C6, which I have already calculated, and it is equal to 84. So I just straight away write 84 here. 9C7, which is 36. 9C8 which is 9 and the 9C9 which is just 1. So that means it is 1 minus 2 to the power 9 is 512 and the sum of all these values is 130. So 1 minus 130 by 512, if you subtract, it comes out to be 382 by 512. And now you can even reduce it to lower form. So it is going to be 191 by 256. So this is your final answer. Done? Great. So let's move to the next question. Now assume that on an average one telephone out of 5 is busy. 10 telephone numbers are randomly selected and called. Find the probability that at least 3 of them will be busy. So what is the value of n here? How many numbers are randomly called? So the value of n is 10. So there are two outcomes, either busy or available. And the phone being busy or available, always it is going to have the same probability across trials. So let's find that probability using the first statement, that is the data point given here. It says one telephone out of 5 is busy. So that means the probability of phone being busy is 1 out of 5. So P is 1 by 5. Now if P is 1 by 5, what will be the value of Q? Q is going to be 4 by 5. So now we have all the values of P, Q and N, and we understand it is a binomial distribution because N is finite, P is having a fixed value across trials, and there are just two outcomes, P and Q. Either the phone is busy or it is not busy. So we need to find the probability that at least 3 of them will be busy. That means probability of x being greater than equal to 3. Before you write this, just write what is x. X is a random variable representing that the probability of the line is busy. Now this is going to be equal to, whenever you have a greater than sign, try to take out the smaller values from 1. So this is 1 minus probability of 0 plus probability of 1 plus probability of 2. Okay, that's it. So let's find these values. So it is 1 minus, n is 10. So it is going to be 10 C0. P is 1 by 5, 1 by 5 to the power of 0 and 4 by 5 to the power of 10 plus 10 C1, 1 by 5 to the power 1 and 4 by 5 to the power 10 minus 1 which is 9 plus 10 C2, 1 by 5 to the power 2 and 4 by 5 to the power of 10 minus 2, that is 8. So this is 1 minus, let's see if there is something that we can take out. Okay, first let's just simplify. 1 into 1 into, this is 10. So it is 4 to the power 10 upon 5 to the power 10 plus 10C1 is 10. 10 into 1 by 5 into 4 to the power 9 upon 5 to the power 9 plus 10C2. 10 into 9 is 90 by 2, 45. So 45 into 1 by 5 square into 4 to the power 8 upon 5 to the power 8. Now as we can see in all these terms, there is 5 to the power 10 in the denominator. So let's take it out. 1 minus 1 by 5 to the power 10. And in the numerators we can take 4 to the power 8 out. So it becomes 4 to the power 8 upon 5 by 5 to the power 10. So let's write what is left inside the bracket. 1 plus 5 to the 10. 4 to the power 8 is gone out. So it is going to be 4 into 2, 8. No, but because we have already taken all the 5s out, let's keep it. So we have taken 5 to the power 10 out. So it is 4 to the power 10 is also out. 4 into 10 is 40. And the next is going to be 5 to the power 10, 4 to the, so it is 45. So in the bracket we have 16 plus 40 plus 45. So it is 1 minus 4 to the power 8 upon 5 to the power 10 into 16 plus 40 plus 45. 40 plus 40, 80, 85, 85 and 16, so it comes out to be 101. So that means the answer is 1 minus 101 into 4 to the power 8 upon 5 to the power 10. So you can leave it in the exponent form, no need to calculate. Great. So let's move to the next question now. In a manufacturing unit inspection, from a lot of 20 baskets which includes 6 defectives, a sample of 2 baskets is drawn at random with replacement. So there is a keyword with replacement that is giving you a hint that it might be related to binomial distribution. Prepare the question itself says prepare the binomial distribution of the number of defective baskets. So focus should be on number of defective baskets. That means P is the probability of the basket being defected, and there are 2 outcomes, defected or non-defected. Calculate the expectation and variance for the random variable x. So x is already given to you. What x is denoting? So a sample of how many baskets is drawn? It is 2. So that means the value of n is 2. Probability of the basket being defected. There are how many defectives? 6 out of 20. So that means P is going to be 6 out of 20 and that is 3 by 10. So that means Q is going to be 1 minus 3 by 10, that is 7 by 10. Now this question is very similar to question number 7 that was solved in the previous video related to probability distribution table. Here the question was, the difference between the 2 questions is that in that question it was without replacement and here it is with replacement. So read the question very carefully whether it is without replacement or with replacement and then accordingly solve it. With replacement means you have to use binomial. Without replacement, you cannot use binomial. So if you want to have a look at this solution, go back to the previous video on probability distribution table and you can have a look at the solution for this question without replacement. Now here because we have with replacement, so let's continue. So it is possible out of 2 baskets, none of them is defected, 1 is defected or 2 are defected. Both are defected, right? So let's find the probabilities. So it is 2C0, P is 3 by 10, 3 by 10 to the power 0, Q is 7 by 10, 7 by 10 to the power 2, 2C0 is 1, 1 into 1 into 7 square upon 10 square, that is 49 by 100. Next, 2C1, 3 by 10 to the power 1 and 7 by 10 to the power 1. 2C1 comes out to be 2. So 2 into 3 by 10 into 7 by 10. 7 3 is 21, 21 2 is 42, 42 by 100. Next is 2C2, 3 by 10 to the power 2 and 7 by 10 to the power 0. 2C2 is 1, 1 into 3 square upon 10 square into 1. So that means this is 9 by 100. Fine. So while you are doing all these calculations, you can just keep a check on this. Sum of all these is anyways 1. So what did the question ask? Calculate the expectation and variance. So you need to find the expectation also and variance also after making the probability distribution. This is going to be n into p. So we just need to multiply n and p. That is 2 into 3 by 10. So the mean is 6 by 10. Or you can write it in lowest form. So it is 3 by 5. So this is the mean. Or you can even convert it to decimal number if you want, 0.6. Next we need to find the variance. So variance is n into p into q. So 2 into 3 by 10 into 7 by 10. So that comes out to be 21 by 50. So this is the variance. Right? So let's move to the next question. In 3 trials of a binomial distribution, the probability of 2 successes is 9 times the probability of 3 successes. How many trials? 3 trials. So that means n is 3. Probability of 2 successes, P for x being equal to 2, is 9 times the probability of 3 successes, x being equal to 3. So this is what is given to you. Find the probability of success. We need to find the value of P. Right? So first let's write what all is given here. So probability of x equals to 2 is 9 times the probability of x being equal to 3. Now we already have n and we need to find P. So we just have the value of n. So it is going to be 3c2 p to the power 2 and q to the power 3 minus 2, that is 1, equals 9 into 3c3 p to the power 3 and q to the power 0. How much is 3c2? 3c2 is 3 only. 3 p square q equals 9 into 1 into p cube. So this gets simplified. 3 3s are 9 and p square gets cancelled and we have only 1 p left here. So that means q equals 3 times p. Now we also know that p and q are equal to 1 always. So in place of q we can write 1 minus p. So 1 minus p is 3p, and when we take p to the other side it becomes 1 equals 4p. So probability of success comes out to be 1 by 4. Easy? Great. So let's move to the next question. An unbiased coin is tossed n times. How many times? N times. Let the random variable x denote the number of times head occurs. So x is denoting number of times head occurs. If p of x equals 1, p of x equals 2 and p of x equals 3 are in AP, find the value of n. So we don't know how many trials, we need to find number of trials, and we understand that the 3 probabilities are in AP. Okay. So probability of x being equal to r is equal to NCR p to the power r and q to the power n minus r. Right? Just written the formula, that's it. Now p is the probability of getting a head. So what is the probability of getting a tail? It is going to be p is 1 by 2 and q is also equal to 1 by 2. So let's put it here. Now because all these 3 are in AP, that means 2 times the probability of x being equal to 2 is equal to the sum of x being equal to 1 and x being equal to 3. So what is this? 2 into NC2 p to the power 2. P and q both are same and both are half. So we can straight away write half to the power n equals probability of x is equal to 1 means NC1 and again half to the power n. And then probability of x is equal to 3 is going to be NC3 and again half to the power n. Because the sum of both p and q is always going, exponents of p and q is always going to be n, so I have straight away written that. So now 1 by 2 to the power n gets cancelled throughout and we have 2 into NC2. How much is NC2? NC2 means n into n minus 1 factorial, n minus 1 upon, because it is actually n minus 1 into n minus 2 factorial, and in the denominator we have 2 factorial into n minus 2 factorial. So here this n minus 2 factorial gets cancelled. So this is NC2. What is NC1? N into n minus 1 upon 1 factorial into n minus 1 factorial. And NC3 is n into n minus 1 into n minus 2 into n minus 3 factorial upon 3 factorial into n minus 3 factorial. So these factorials get cancelled and we have something simpler left. So let's see. This 2 and 2 also gets cancelled. So we have n into n minus 1 equals n plus n into n minus 1 into n minus 2 upon 3 factorial, which is 6. Again, we can divide the entire equation by n because we can see n is here in all the terms. So if we divide the entire equation by n, we get n minus 1 equals n plus 1 plus n minus 1 into n minus 2 upon 6. So let's bring this 1 to the other side. So it becomes n minus 2 equals n minus 1 into n minus 2 upon 6. Now this n minus 2 also gets cancelled, and when we do cross multiplication, we get 6 is equal to n minus 1. Bring this 1 to the other side, that means the value of n is 4. This is what we had to find. So the number of trials is 7. Clear? Great. So let's move to the next question. The probability that Rohit will hit a shooting target is 2 by 3. While preparing for an international shooting competition, Rohit aims to achieve probability of hitting the target at least once. So probability of hitting the target x being greater than equal to 1. At least once means greater than equal to 1 to be 0.99. So this is what he is wanting to achieve. What is the minimum number of chances that he must shoot to attain the probability? So that means you need to find the value of n. So again, it is a binomial question distribution because you have two outcomes, either it is hitting or it is missing. So probability of hitting is 2 by 3. Probability of hitting the target is 2 by 3, and that means q is 1 by 3. We need to find the value of n such that the probability of hitting the target at least once is 0.99, right? So that means probability of hitting the target, so let's start with, let the number of trials be n. Because whenever you are introducing any variable, let the number of trials be n. So that means probability of x is greater than equal to 1. Probability of x being greater than equal to 1 is 0.99. Now what is the probability of x being greater than 1? So this can be written as 1 minus probability of x being less than 1. We can write this, yes? And less than 1 means 0. So this can also be written as 1 minus probability of 0. So this is equal to 0.99. So let's put the binomial distribution formula here. 1 minus, it is nc0, p is 2 by 3 to the power 0 and 1 by 3 to the power n equals 0.99. So nc0 1 minus nc0 is 1. 1 into 2 by 3 to the power 0 is again 1. 1 by 3 to the power n equals 0.99. That means 1 minus 1 by 3 to the power n equals 0.99. Bring this to the left side and 1 upon 3 to the power n to the right side. So it becomes 1 minus 0.99 equals 1 upon 3 to the power n. 1 minus 0.99 is equal to 0.01. So that means this is 0.01 equals 1 by 3 to the power n. Cross multiply. So it is 3 to the power n equals 1 upon 0.01, that is 100. So what value of n should be there? N, 3 3s are 9, 9 9s are 81. N to the power 4 is 81. N to the power 5 is going to be bigger than that. So that means he should at least try for 5 times. So the number of trials he should be trying is 5 times, so that the chances of hitting the target at least once comes out to be 0.99. So the value of n is 5 here. Next question. A coin is biased. Now this is not an unbiased coin, it is a biased coin, so that the head is 3 times likely to occur as tail. If the coin is tossed twice, so 2 times the experiment is being done, the value of n is 2, then find the probability distribution of number of tails. That means number of tails needs to be represented by P and number of heads is going to be represented by Q. Find the mean of the number of tails. So now we understand that the first statement says the head is 3 times likely to occur as a tail. So that means the probability of head is Q, the probability of tail is P. So this means head is 3 times likely to occur than tail. That means Q is equal to 3P. And we also know that P plus Q is always 1. So P plus Q is 1. So that means in place of P, P is 1 by 4. So this also means that the value of Q is 3 by 4, and N is already given in the question. N is 2. So we have all the three parameters P, Q and N, and now how many tails can be there? So because N is 2, so the possible values of X can be 0, 1 and 2. That means you do not get any tail, one tail or maybe two tails, right? So it is going to be 2C0 P to the power R. That means 1 by 4 to the power 0 and then 3 by 4 to the power 2. So this is 1 into 1 into 3 square upon 4 square. 3 square is 9. 9 by 16. Next 2C1. 1 by 4 to the power 1 and 3 by 4 to the power 1. So this is equal to 2 into 1 by 4 into 3 by 4. That comes out to be 6 by 16. Next 2C2. 1 by 4 whole square and 3 by 4 to the power 0. So this is 2C2 is 1. 1 into 1 by 4 square into 1. That comes out to be 1 by 16. So these are the probabilities. Now the question said find the mean of the number of tails. So we have created the probability distribution. This work is done. Now let's find the mean. So mean is N into P. So it is number of trials is 2. 2 into P is 1 by 4. 1 by 2. So this is the mean. Easy? Yes, great. So let's move to the next question. In a binomial distribution, the sum of the mean and variance is 1.8. Find the probability of two successes if the event was conducted 5 times. Now we have done so many questions. You can give it a try. Try to do this question on your own. Pause the video and give it a try. Okay, so let's see how to solve this. You are given the sum of the mean and variance as 1.8. The mean is N into P and the variance is what? Variance is N into P into Q. So the sum of these two, that means N into P plus N into P into Q is given to you as 1.8. Find the probability of two successes if the event was conducted 5 times. So that means the value of N is 5 and you need to find the probability of two successes. So let's put the value of N as 5 here and take NP out. So if you take NP out, it becomes NP into 1 plus Q equals 1.8. N is 5. 5P into 1 plus Q is 1.8. That means P into 1 plus Q is 1.8 upon 5. 5 3s are 15 and 30 5s are 30. So P into 1 plus Q is 0.36. Now because P can be written as 1 minus Q, so this becomes 1 minus Q into 1 plus Q equals 0.36. This is A plus B into A minus B. A square minus B square comes out to be 0.36. That means Q square is equal to 1 minus 0.36, which is 0.64. So this means Q is 0.8. Square root of 0.64 is 0.8. Now we have the value of Q. So let's find P. So because Q is 0.8, P is going to be 1 minus 0.8, that is 0.2. And the number of trials is given, that is 5. And we need to find the probability of two successes. So we need to find probability of R being 2. So 5C2, 0.2 to the power 2 and 0.8 to the power 5 minus 2, that is 3. 5C2, how much is this? 10. 10 into 2 square upon 100 into 8 8 is 64, 8 4 is 512 upon 1000. So let me write 4 here. 2 square is 4. So one of the 0 gets cancelled. 2048 upon or you can leave it as a fraction also. So probability of x being equal to 2 comes out to be 0.2048. Find the probability of 2 successes if the event was conducted 5 times. So we have got the answer, probability of 2 successes when the event was conducted 5 times. Okay, great. So let's move to the next question. It says if the sum and product of the mean and variance of binomial distribution are 1.8 and 0.8 respectively, find the probability distribution and the probability of at least one success. So you need to create the probability distribution table also and the probability of at least one success. So this is what we need to find, and what is given to us is the sum and product of mean and variance. So that means the first thing given to you is NP plus NPQ is equal to 1.8, and the other thing is product. So that means n square into p square into q is 0.8. So first let's try to solve these two equations, find the value of np and q, and once we have all the three values we can use it to find the probability of x being greater than equal to 1. Right? So let's try to solve these two equations. If you look at both these, the first equation has 1 as the degree. So power of n, p, q, everything is 1. And in the second one we have n square and q square. So let's n square and p square. So mark this as 1, mark this as 2. Now if we do square of the first equation and divide it by the second equation, what do we get? Square of the first, that means n square p square into 1 plus q whole square upon n square p square q. On the right side we'll have 1.8 square upon 0.8. So here n square p square gets cancelled. So we have 1 plus q whole square upon q is equal to, let's simplify this, 18 into 18 upon 8 into 10. So this becomes 81 by 10. Let's cross multiply. So it is 10 into 1 plus q square plus 2q, and this is equal to 81q. 10 plus 10q square plus 20q equals 81q. Oh, there's a mistake because it was 2 here, so this should be 20, not 10. So here it should be 20. So let's make it 20 and then solve it further. So this is going to be 40. So the equation is 20q square plus 40q minus 81q plus 20 equals 0. So it is equal to 20q square minus 41q plus 20 equals 0. Now let's factorize. 20 into 20 becomes 400. So what are the factors of 400? That will give you a sum of 41. So if we just do some hit and try, it is going to be 16 and 25. Minus 16 minus 25 adds up to 41 and their product is 400. So let's factorize this further. 20q square minus 16q minus 25q plus 20 equals 0. That means 4q. So it is 5q minus 4. 5q minus 4 again. Take this common. So the factors are 5q minus 4 and 4q minus 5. So that means the value of q is either 4 by 5 or 5 by 4. Now because q is referring to the probability, that means it cannot be greater than 1. You have to write this. Specify the reason why you are rejecting 5 by 4, as q is probability. So q should be less than 1. That means the value of q here is 4 by 5. Now because q is 4 by 5, that means p is going to be 1 by 5, and using these values of p and q, we can find the value of n. So let's put both the values of p and q in equation number 1. So p is 1 by 5, q is 4 by 5. Yes? So now this becomes n 9 by 5 and 1.8 into 5. 5, this becomes 9.0. So that means n is 9 into 5 by 9. 9 gets cancelled, so the value of n comes out to be 5. Now we have the value of n also, we have the value of p and q also. All the three values we have, and now let's see what we need to find. We need to find the probability of at least one success. So that means we need probability of x being greater than equal to 1. So this is equal to 1 minus probability of x being less than 1. Less than 1 means probability of x being equal to 0. So let's write the formula here, binomial distribution. So it is going to be n is 5. So it is going to be 5c0, 1 by 5 to the power 0 and 4 by 5 to the power 5. So this is 1 minus 1 into 1 into 4 to the power 5 upon 5 to the power 5. 1 minus 4 to the power 5 upon 5 to the power 5. So you can leave it here in the exponent form, but because these are not very big exponents, so you can even solve it completely and find the final fraction. So it is equal to 1 minus 1024 upon 3125. So that comes out to be, when you subtract 3125 minus 1024, it is 2101 upon 3125. So if you solve it up to here, it's great. Otherwise, you can leave it here also in the exponent form. So hope you understood the question. So the objective here is always to find the value of n, p and q, and then just apply binomial distribution. So let's move to the next question. The difference between mean and variance of a binomial distribution is 1. So the difference is given to you now between the mean and variance. So that means np minus npq is 1, and the difference of their squares is 11. Difference of their squares, that means n square p square minus n square p square q square is equal to 11. So if I take np common out, it becomes 1 minus q, and this is 1. And here also if I take n square p square out, it becomes 1 minus q square, and this is 11. Now here, because the powers are 2 and here it is 1 in the first equation, so let's square the first equation and divide it by the second equation. So this becomes equal to n square p square 1 minus q whole square upon n square p square into 1 minus q square, and this is equal to 1 square upon 11. N square p square gets cancelled. 1 minus q whole square upon 1 minus q square can be written as 1 plus q into 1 minus q, and this is equal to 1 upon 11. So 1 minus q gets cancelled here, and when we do cross multiplication, we have 11 into 1 minus q equals 1 plus q. So let's solve this equation. 11 minus 11q equals 1 plus q. This becomes 12q, and 11 minus 1 becomes 10. So that means the value of q is 10 by 12, that is 5 by 6. And this also means that the value of p is 1 by 6. Now what is needed? Find the distribution. If the question says find the distribution, how do we write? So we just write that the binomial distribution is always q plus p whole to the power of n. That means 5 by 6 plus 1 by 6 whole to the power n in this case. So this is the binomial distribution. 400 times and it shows heads 220 times. Discuss whether the coin is unbiased or not. Now this depends on the range between from the mean to 2 times the standard deviation or maybe 3 times the standard deviation. So that means we need the values of mean and the standard deviation to find whether the coin is biased or not. So let's see. A coin is tossed 400 times. That means n is given to you as 400. It shows heads 220 times. Probability of head is 1 by 2 and probability of tail is also 1 by 2. Let's assume that it is not biased. So that's why the probabilities are equal here. And let's first find the mean and standard deviation. So the mean here is going to be equal to n into p, that is 400 into 1 by 2, that comes out to be 200. What is the standard deviation? Standard deviation is n into p into q and square root of this. So it is going to be 400 into 1 by 2 into 1 by 2 square root. So it is square root of 100 and that comes out to be 10. Now if we have a value which is in the range 2 sigma. 2 sigma means 2 into 10 is 20 plus 20 and here minus 20. If we have a value in this range, that means it is not biased. It is an unbiased coin. If the value is between 2 sigma till 3 sigma. What is 3 sigma? 3 times are 30. So it is 200 plus 30. So this is the mean. 200 plus 30 is 230. Then it is in this range 220 to 230. Then that means it may be biased, may not be biased. And if the value goes beyond 230, then it is for sure biased. Fine. So now the question says it shows 220 times head. So it is exactly here. So that means the coin maybe perhaps it is biased. So you are not sure whether the coin is biased or not because it is lying in this range 2 sigma to 3 sigma. It is exactly 2 sigma, crossing mean plus 2 sigma, right? So because 200 plus 2 into this is equal to 220. So it is mu plus 2 sigma comes out to be 220 and the given value is also exactly 220. That means the coin may be biased. So this is what you need to specify. So let's move to the next question. In the mean of a binomial distribution is 81. Then find the interval in which standard deviation of the binomial distribution lies. So you are given that the mean is 81. That means n into p is 81. You have to find the interval in which the standard deviation of the binomial distribution lies. So what is standard deviation? Standard deviation is square root of npq and we have np as 81. So let's put it here 81q and then square root, that becomes 9 square root q. So we need to find the range for this. Now because q, probability of failure, q is always less than 1. Q is always less than 1 because it is a probability. So that means square root of q will also be less than 1. It is going to be a decimal number. Now if this is a decimal number, that means the standard deviation is going to be less than 9 because 9 into a proper fraction, a value less than 1. So that means standard deviation is less than 1 and standard deviation has to be greater than or equal to 0. So this means, combining these two conditions means that the standard deviation lies in the interval 0 to 9 where 9 is open-ended and 0 is closed. So this is your answer. Okay, next question. How many times Sunil tossed a fair coin so that the probability of getting at least one head is more than 90%? Now again the probabilities are involving head and tail. So the probability of head is 1 by 2 and probability of tail is also 1 by 2. How many times means we need to find the value of n. Probability of getting at least one head. At least one head means probability of x being greater than or equal to 1 is more than 90%. So this is more than 90%. This is what is given to you. So that means probability of x being greater than or equal to 1 can be written as 1 minus probability of x being less than 1. Let's put it, we need to find the value of n. NC0 and 1 by 2 to the power n. 0. This is equal to 0.90. NC0 is 1. So that means 1 minus 1 upon 2 to the power n is greater than equal to 0.90. This means if you take 1 by 2 to the power 10 to the right side and 0.9 to the left, 1 minus 0.9 is greater than equal to 1 by 2 to the power n. 1 minus 0.9 is 0.1. So 0.1 is greater than equal to 1 by 2 to the power n. Let's do a cross multiplication. So it is 2 to the power n is greater than equal to 1 upon 0.1. 1 upon 0.1 is 10. So that means 2 to the power n is greater than equal to 10. 2 cube is 248. 2 cube is 8. So that means n should be at least 4. It should be greater than equal to 4. Don't write equal to 4. It has to be at least greater than 4, because the question says how many times should toss a fair coin so that the probability of at least one hit is more than, because it is given more than. It is not given equal to 90%. It is more than. So that means n should be at least 4. Understood? Great. A fair coin is tossed 6 times. What is the probability of getting at least 4 heads? So here you are given the number of tosses, that is 6. So n is 6. What is the probability of getting at least 4 heads? Because it is again coin, so p is 1 by 2 and q is also 1 by 2. We have all the 3 values. Probability of getting at least 4 heads means p of x being greater than equal to 4. Maximum value possible is 6. So this is going to be probability of getting 4, probability of getting 5 heads and probability of getting 6 heads all put together. So this is n is 6. Let's write it here also. So it is going to be 6c4 and 1 by 2 whole to the power 6 plus 6c5 1 by 2 whole to the power 6 plus 6c6 1 by 2 whole to the power 6. So this is 1 by 2 whole to the power 6. How much is 6c4? 30 by 2 and it will be 15. 6c5 is 6 and 6c6 is 1. 15, 21 and 122. So it comes out to be 22 by 64 and if you reduce it, 11 by 42. So this is the probability of getting at least 4 heads. Now the last question of this video, and it is a very important question. Not the last, second last question. If the mean and variance of a binomial distribution are 4 by 3 and 8 by 9, find the probability of x being equal to 1. So you are given that the mean n into p is 4 by 3 and variance is n into p into q is 8 by 9. So if I put the value of np as 4 by 3 in this, I get 4 by 3 q as 8 by 9. So that means the value of q is 8 by 9 into 3 by 4. So this comes out to be 2 by 3. Now if we have the value of q as 2 by 3, p is 1 by 3. And if p is 1 by 3, n into 1 by 3 is equal to 4 by 3. So that gives us the value of n as 4. So we have the value of n as 4, p is 1 by 3 and q is 2 by 3. Now we have all the 3 values. We can easily find the probability of x being equal to 1. So probability of x being equal to 1 is going to be 4c1 1 by 3 to the power 1 and 2 by 3 to the power 4 minus 1, that is 3. So 4c1 is going to be 4 into 1 by 3 into 2 cube upon 3 cube. 2, 4, 8, 8 was a 32 and 3 cube is 3 cube into 3, this is 81. So the probability is 32 by 81. Great? Done? Okay, the last very important question, which is a little different. It is not exactly binomial distribution, but partly binomial and an extension of it. So let's understand the question first. An unbiased die is thrown again and again. Until 3 6s are obtained, find the probability of obtaining a third 6 in the 6th throw. Now when you have a question like this, the number of throws is limited to 6. So n is limited to 6. It is not going to be beyond that. And either you get a 6 or you don't get a 6. So the number of trials is limited. Either you get a 6 or you don't get a 6. Two outcomes are there. Probability of getting a 6. If you get a 6, it is just 1 out of all the 6 possible outcomes. Probability of not getting a 6 is going to be 5 by 6. Now it says probability of obtaining a third 6 in the 6th row of the dice. 1, 2, 3, 4, 5 throws, and in the 6th throw you get a 6 here. What is the probability of this? So this means that in the first 5 throws you have got 2 6s. 2 times you got 6 in the first 5 throws, and in the last one you definitely got a 6. Right? So this is what we need to calculate. So what is the probability of getting 2 6s in 5 throws? So it is going to be 5c 2. What is the probability of getting a 6? 1 by 6. 1 by 6 square and 5 by 6 to the power 5 minus 2 is 3. What is the probability of getting a 6 multiplied by 1 by 6? Right? So this is what we need to calculate. 5c2. How much is this? 20 by 2, it is 10. 10 into 1 by 6 square into 5 cube by 6 cube into 1 by 6. 5 cube is 125, so it is 1250 upon 6 to the power 6. 1250 upon 46656. Both are even numbers, at least you can cancel it once, and this comes out to be 625 upon divided by 2. 23328. So this is the probability of getting third 6 in the 6th throw of the die. Now let's wrap up and have a look at the common mistakes, common areas where you could make mistakes while solving questions related to binomial distribution. Number 1, check if the question is for binomial distribution. So number of trials should be finite. Number 2, two possible outcomes, success and failure, and probability of success is same across all the trials. So all the 3 conditions should be met whenever you see a question and you need to decide whether it is related to binomial distribution or not. It should use the words with the replacement. If it is without replacement, then it is for sure not binomial distribution. Read the question very carefully to understand the values of n and p. For example, for the questions that were on cards, n is not 52. N is how many trials? So n is always a different value than 52. What is p? Whenever you have to find the probability of getting number of heads or number of tails. So whatever is the random variable referring to, whether it is getting a head or a tail, mark that as p. Read the questioning statement carefully and understand what is p. And the opposite of that, the other outcome is q. So it's very important that you identify p and q carefully. P should always refer to the probability of the event as per what is needed in the question, and q is the other event. Use the sum of probabilities p and q is always 1. And when you are doing NCR calculations, always remember NC0, NCn is 1. You need not waste time or think about what is the value. And take care that the sum of exponents of p and q is always equal to n. While just writing it again and again, we might tend to make mistakes. So just keep a watch that the values, the exponents add up to n in all the distributions that you are using. Now the questions involving at most or at least. Understand what is being asked. X is less than equal to r in case of at most and greater than equal to r. For finding a value greater than r, if we have limited and we understand, we can go ahead till n, or we can use opposite of that, that is 1 minus x less than r. So whichever is easier to calculate, use that approach. So this is all about probability that we have in class 12 applied maths curriculum. If you want the complete formula deck for Class 12 Applied Maths, you can visit my website www.boundlessmaths.com, where you can find the formula deck for all the formulas of your entire syllabus for easy and quick recap anytime. So stay tuned for our next video on Poisson distribution. I hope you like the video. Share the video with your friends. Subscribe to the channel if not done so far. Keep watching, keep learning. See you in the next video.